Yeah, so I'm just once again, hello everyone. I just started recording this, so just that we'll just quickly take some notes, kind of thing. So just now, Nikhil was. I'll just remove this. Nikhil was talking about energy efficient computing. Did everybody understand this? Anybody want to ask a question or doubt regarding this? Did you get what he is saying? Energy efficient computing. Did everyone understand what he was saying?
Need a little bit of elaboration to
Who is
understand.
this? Okay,
Sandeep.
So we
Sandeep
need
was asking for a little
to
bit
know
of.
more. Yeah.
Sir, so around 2007, so two engineers in Google, they published a paper called The Case for Energy Proportional Computing. And they had two key findings in that paper. One was servers are usually utilized on like 10% to 50% of their maximum capacity. And even when idle, a server can consume like 50% of its peak energy consumption. So their idea was that energy proportional servers would bring like huge energy savings in huge data centers like Google. So that
Okay,
was
so
how this all kicked off.
I'll just once again rephrase the topic. So saving energy in what you call data centers. So I mean, does this new topic make it little easy to understand? Saving energy in data centers. I'll just come back in a minute. Yeah, sorry, I'm just back again. I was with my kid, so he interrupted me. So anyway, so let's get back to this topic. So 2007, you are saying some uh, research article by Google.
Yes, sir.
Google employees. So one of the questions you asked is that does this come under the scope of this particular course? And the answer is yes. You can consider this the scope of this course. Anything can be anything related to energy will definitely come under the scope of this course. So that's it. So you can see now from here, what do we do? So you, as a part of this course, you can explore this topic further. In maybe you can kind of do your own analysis, your own understanding of it, your own case study, some kind of thing you can do. That given some kind of computing work, how much computing energy is required, whether it is worth spending that much energy to do this particular computing, or if there are some what you call idle servers, can that idle servers be shut down to save the energy? All these things you can further study, and then again you can explain. So basically what the message I'm trying to tell you is that you explore the subject yourself. As you mentioned that you searched and you found a paper, and you explore the subject, and then you share the knowledge with your fellow students using this as a platform. See, for example, last week we had 2 sessions which we did not take, so which amounts to about 3 hours of time. Imagine each of you spend 3 hours searching the internet and on the subject of energy and energy management. You could have learned some points, right? Maybe some 10 bullet points or something. And then if you can explain that, taking 5 minutes, explain that to each other in the class, it would be very interesting, right? So now we have about 18 people. So anyway, so Nikhil, you want to add something to what you just now said? Add some more details?
I can add a couple more points here.
Definitely, go ahead and add a couple of points.
One thing people have found at the software level is code that is multi-threaded, like concurrent code, is much more energy efficient than single-threaded code. The idea is that for single-threaded code, it'll take longer to run, and because of that, the server's idle power consumed will be a lot. On the other hand, if the code is multi-threaded, it runs for a shorter time, even if it's slightly less efficient than single-threaded code. And because of that, they found it to be more efficient. And currently, quite an amount of research is going on such that you measure a computer's like energy consumed, and you predict if it's idle or not, and you can shut down based on that. In fact, people at IITH itself are doing that kind of research.
Okay.
So that's a couple of points I wanted to say. Sir.
So now, just I'm ultimately I just wrote down one point only. That is, multi-threaded coding will consume lesser energy. Now the question goes to the rest of the people. Do you know what is this multi-threading? Now you can ask a question. How is it related to energy efficiency? All these things, but don't try to restrict knowledge at any point of time. Just simply explore and find out new things. If you don't know what is multi-threading, so again spend half an hour searching about multi-threading, and then you will know something about multi-threaded coding and things like that. So anyway, so does anybody know what is don't know what is multi-threading, and you want to ask right now what is multi-threading? So always compared to so apparently nobody want to ask her, so it is fine. So yeah.
So
Okay.
I do not know what is multi-threaded coding.
Okay, so very good. So somebody is asking, we do not know about multi-threaded coding. So again, you can just one simple answer is you can just find out yourself. Maybe you can write down notes for yourself that okay, I will invest some time learning about multi-threaded coding. Whereas this course, energy management, will become an excuse for you to learn about that. Those who don't know, please find out about multi-threaded coding. Meanwhile, anybody else, see today we have about 18, 19 people in the call. Anybody else want to say what is multi-threaded coding? Anybody wants to add? What is multi-threaded coding? Nobody wants to say? So what about Nikhil? See, you
Um,
said multi-threaded
so,
coding will consume less energy. So obviously you had read this in some online resource. And so before you accept it as it is, can you can you justify, or you'll have to know at least?
yes, sir.
Yeah.
I was a bit imprecise when I called it multi-threading, so I would probably have to say multi-processor, but both are usually treated as same.
Okay.
Whenever we like buy a laptop or some server or something, they say
Okay.
this server has 4 cores or 5 cores, or someone says this server runs at this speed. So multi-core is the idea that instead of only using one core at any given point of time, we try to use all cores. The problem is that coordination between different cores or different threads causes some additional work, and it's a bit hard to do for a programmer. So people tend not to take advantage of it quite a bit. But what happens in a lot of these servers is when you run single threaded code, it's not the only the processor that's on, lots of other peripherals, like let's say the UPS is on, some fan is on, etc. So because of that, all these things consume energy. And for let's say multi-threaded code runs like 3 times faster. So these things are run for 1/3 of the time that they would be run when single-threaded code is used. In fact, sometimes the gain is much more. Multi-threaded code, depending on the server, can run like maybe even 10 times faster. So all the energy consumed by these peripherals, etc., is reduced a lot.
Okay.
And that was
I
the
think,
idea behind these people proposing
okay.
that.
I think beyond this, people can always search online, with these terms. But any further questions anybody has on this? I know the answer may not be 100% convincing, or maybe it may be 100% convincing. But still, anybody wants to ask any question, any doubt on this? Okay, so there are no further questions on this, but I will ask a question. So, in your work, this question is to Nikhil. So,
Sir,
how much of energy are we talking about?
uh, I'm
So,
not sure about the
is
numbers.
it in milliwatts, or is it in watts, or is it in kilowatts, kW, or
So
is it in megawatts?
for my work personally, like this would probably be impactful in like watts per day.
Okay,
Uh,
this will be power.
watts power, yeah, it would be impacting in watts for my work.
Okay,
But there are estimates that like around 10 to 20% of like the world's energy is used in software and data centers, etc. And we are talking like 10 to 20% savings in that for just by doing simple improvements. So that's like 1 to 2% of the world's energy saved just with very simple improvements. So at
okay.
that level, it matters a lot.
Okay, so what you are saying is 10 to 20% of world's energy consumption
Is in
comes from
computation, sir.
computation. Yes. So therefore, if you save in this section, in this segment, or it will be beneficial.
And the idea is this should be very easy to save, like compared to making hardware changes or even huge structural changes.
Just a minute. Yeah. So I'm back again. So yeah. So we were talking about world's energy company. If you save a small segment in this, it will still be significant.
Yes, sir.
Okay. So anybody wants to ask, and obviously now here it will be in gigawatt hours range. Okay. So yeah.
So apparently, like data centers, not all computation, just data centers,
Yeah.
consume around 400 terawatts per year. Terawatt hours, my bad.
Data centers. Okay.
Just data
So
centers.
so one more point is saying data centers alone consume
Around 400 terawatts per year, sir.
400 TWH.
Yes, sir.
So, by the way, so when we mention this kind of numbers, you should get some understanding of what this number actually means. Okay. So, what does a 400 terawatt hour per year means? So, can we have some kind of see, just by saying 400 terawatt hour, it doesn't make sense. So, can we have some kind of understanding of this number?
I'm not sure if it helps, but the estimate is this is like 2 to 4% of world's global energy consumption.
So that is again to the world's global energy consumption. But how doesn't it contradict this point? 10 to 20%.
That is for all computations and not just data centers. So
Okay.
that includes my computer and so on.
Okay. So this computation involves not just data centers but outside computers also,
Yes, sir.
which are in our houses and all. Okay. But anyway, so let's try to understand this number 400 terawatt hour. So, anybody knows how many units you have consumed this month in your house? Those who are now today attending, how many units of energy are you consuming in your? If you look at your electricity bill.
So nearly 200 to 250 per month.
Okay, so
Units.
is that Sushant?
Yes, sir. Yes.
Okay. So okay, good. So one example is let's take it as 200 units per month per house. Okay. So one I mean residential example, one student is mentioned. Did anybody had a chance to look at your electricity bill and see how many units your house is consuming? Any other numbers you want to propose? Anybody else? So you don't see your electricity bill? You are living in your house, right? What is your electricity bill? And how many units did you consume? So definitely now that you are doing a course in energy management, so the first step of energy management is knowing how much energy you are consuming. Okay. So now we'll go with this example, 200 units. So therefore, how many houses can we support with this? So let us see. So 200 units means kWh, kilowatt hour. Okay. Multiplied by 12 because this is kilowatt hour per month. Okay. And multiplied by 12 months. So this will be the energy per house. Okay. So into some X number of houses should add up to, I mean, I wanted to find out equivalent number of houses, terawatt hours, right? So from this, what is X? X equal to 400 tera divided by 200 multiplied by 12 kilo. Okay. So what is tera by kilo? Tera means how many zeros?
1,000 for tera to giga and another 1,000 for giga to mega.
Okay, that's good way of thinking. 1,000 for tera to giga and another 1,000 for tera to kilo. Okay, so already we are at kilo. So I'll
No,
cancel
sir, I think it's one more 1,000.
tera to giga. Okay, sorry, giga to
Tera
mega.
to giga to mega and then to kilo.
So
Tera to giga, giga to mega, mega to kilo.
divided by 200 multiplied by 12. This denominator also is in kilo. So both are in kilos, so we can cancel out. Okay, so let's do this. I'll take this, go to Google, and then I remove the case. I'll cancel myself. So I'm getting this many houses. Okay. Okay, good. So automatically font also is coming big. Okay, anyway. So what I'm saying is, okay, again 1, 2, 3. So here I'll make comma and again 166 million houses, or in our Indian terminology, it will be 1 million is 10 lakhs, right? So 16 crore houses. Am I correct? Yeah.
Yes, sir. 16.66 crore.
So how much energy 16.66 crores houses consume in 1 year? That much energy our data centers are consuming. Data centers across the world, they are consuming. So therefore, it's a huge amount. So that's why I want you to get this sense of what is this 400 terawatt hours, right? So therefore, if any one of you, like these people in Google employees who are doing research, any one of you can spend some time and find out more about this thing and develop some kind of a monitoring. You say there's a data center and you're monitoring how many servers are running, what servers are idle, what servers are working, and then you switch off some cores, all that kind of stuff. So it can be worth a lot in saving the energy. So I think we had a good amount of discussion on this topic of energy efficient computing. Okay, so let me highlight this topic now. Okay, anybody wants to add more questions? Take this discussion in some other direction. So again, I am asking one more question to Nikhil. So Nikhil, how much time did you spend on coming up with these points?
So this was already part of a project that I was working on this summer.
Okay.
So I spent quite a bit of time that time, but now I was just using my previous notes.
Okay. Okay. So what was the conclusion of your whatever internship project?
I was actually working on like shutting down computers that were idle and all that.
Okay.
So it was not my project per se, but I was just a part of it. And one of the conclusions was if you could do that, you could save like maybe around 5% of the energy, which is not very much for us. But when you look at the data center scale, it is a lot, sir.
Okay. What way was this study? How did you do this study? I mean, you are a part of a team, you're saying, but how did you do this? How did you come up with the number 5%?
It was largely measurement and calculation, sir. It was more on the lines of how would I put it? An issue if we shut off computers a lot is rebooting them again takes a lot of energy. And sometimes we can't see if it is if it is really idle or it's idle because something is blocked. So we have to be conservative. Because of that, people usually don't tend to shut down unless they're absolutely sure. And we just did a basic calculation of what would happen if we went ahead with the predictions that the system was making, whether a system like the computer was idle or not. It was estimated that we could save around 5%. That is a very conservative estimate. Okay,
so your methodology that you are using is basically some measurements you have taken and then did some basic calculations.
Yes, sir.
Did you use any software or anything?
No, sir. So
Okay.
the main area was not related to the energy itself. It was related to something else. So this was just a small part of it.
Okay. And I mean, just see why I'm asking these questions is I would like others to know that what skills is needed, what kind of thought process is needed to do some kind of work like this, to come up with some kind of conclusion like this. So you said 5%, could it be 7%? How to make it 15% or whatever, this kind of things. But what kind of things? So you're talking about measurement, doing some calculations, no software was used. So I mean, pretty much, if people spend time and energy, they should be able to do this kind of work. Okay, so I think we'll. Any other questions anybody has on this?
Sir, it is given as a type of coding, but recently, a few months back, I just read one article in our technical magazine that if we even delete our unnecessary emails, that also contributes of saving of memory in the data center, followed by saving in AC, and means ultimate the energy.
Okay, so what you are saying is data centers store huge amount of data. Sorry. Of several million users, or I'll simply say millions of users. So the storage also includes junk emails. JUNK, right? Junk emails. So what you are saying is, if junk emails are deleted, then
We can save a lot on energy.
storage will be less and energy consumption will be less. So then let's ask this question. How many of you delete your junk emails, and how many of you are willing to delete junk emails so that for the data centers data energy will be saved? You understood my question, right? Any comments on this point?
Sir, in this only one follow-up action like Google has taken in their Google Drive. Nowadays, if you keep something in trash, so within 1 month it will be auto-deleted.
Yeah. So one of the what you call steps is auto delete after 1 month. Okay. So yeah, anybody wants to comment on this? Do you believe this is correct? Okay, so good. So let's continue. Let's any other point anybody wants to discuss apart from this energy efficient computing? This is for everyone in the call.
Sir, actually, the article was contradictory in that way that we are following like paperless office, but at another way, with this paperless office, means our consumption is not getting reduced. Means ultimately we are harming the means nature ultimately. Basically, we are not using paper, but many data, unnecessary data, means it ultimately gives a negative impact on the environment as well as more energy consumption.
Okay, so I have kept a question mark that one reason for going for paperless office is, okay, papers are coming from trees and we are cutting down trees for writing all these papers, getting the papers. So if we don't use papers, then less trees are cut, and then it is better for the environment. But then now you are saying that it may be ultimately harming the environment, in the form of increased storage and increased energy consumption. Okay, so this is again a question. Okay, so again, this is matter to explore. Okay, / investigate. So again, see, you should have some kind of analytic mind. See, this kind of topic when it comes forward, do you believe that this is true, that paperless office? See, or let's say I do a poll, for example. Okay, let's say poll. So, and I'll say paperless office. Okay, let me phrase it. Will be more harmful to the environment compared to paper-based office. So here I'll say yes, no, don't know. Yeah. So how many want to say yes? So
Yes.
those who are on the call, how many of you want to say yes? Just because somebody has written an article, I mean, what do you think? I mean, if you switch on your brain,
I would go for no, sir.
who is going for no?
Nikhil, sir. This is Nikhil.
So anybody else wants to answer? See, there are many people in the call, close to 18 people, right? So let's see how many will come forward and make a vote. So who wants to vote? Anybody else? Just, I mean, whatever time.
I also thinking no, sir.
Okay, so no is one more. Okay, just tell your name and then say your this thing. Let's do some quick poll. Fast.
So, currently, I think it will be no, but maybe in the future it can be yes. So, for now, it will be no.
So as of 2020, no, but in future may become yes. So in other words, what you are saying is people will be using too much of data analysis, that it will become more harmful.
Yes, sir. So
See, this comparison is keeping other things equal. So, for example, let's say there are 100 students, and I want to conduct exam. Okay, so I can print 100 question papers and then give 100 people additionals and answer sheets, and they are writing, and then we are putting in a envelope and correcting. So that is a paper-based examination. And another thing will be paperless examination, where I'll send a Google form and then you will calculate and then you will fill up these answers online. And then, so keeping the usage same, if you compare paper-based and paperless based, which one is more harmful to the environment? Of course, both will consume energy, both will contribute to, harming to the environment. See, ultimately, if everybody sits in their respective houses and does meditation, then the environment will be less harmful compared. But then we can't do that. So we'll have to study, we'll have to conduct exams and all these things, and we have to do our office work. So now we are saying, for the same amount of work, which option you want to support? Yeah, more. I got only 4 votes. So let's not waste much time. Next 2 minutes, I want everybody to say. More people should vote. The question is clear on your screen, right? Yeah, go ahead. So, what about Rizvi, and Vipul,
Yes,
Sita, Chandra? Some people I remember, Sandeep. All of you just think about this. Paperless office will be more harmful to environment compared to paper-based office. At least you can say don't know. Yeah. Why is it taking so much time to express your opinion? Fast. What do you think? Vipul, Rizvi,
yes, I said no.
you said yes?
I said no.
No, okay.
Yes.
And others?
So I already said this point was mentioned by me only. As of 2020, it's no. But in future, it
Okay,
may
good.
become yes.
Then I already counted. Okay. So, other people. See, is everybody just attending the call and keeping in mute and then keeping the phone in maybe in a cupboard and then watching TV or something? Is it like that? Online classes? So I consider it like that only, right? See, I am just asking yes or no and don't know also. Only 5 people responded. That means only 5 people are listening.
Sir, if we take recycling thing into consideration, I think
Who is this?
no, because Sandilia, sir.
Okay, Sandilia. Okay, what is your answer?
So I'd say no.
Okay, and what is your explanation? What's
So
your
the recycling of e-waste would be hard compared to the paper recycling. So few years down the line, it will be hard to recycle all of the e-waste which we are like accumulating because of this. So
Okay, good. So it's a good point, right? So e-waste, that is electronic waste, recycling will be harder than recycling. Paper is anyway biodegradable. Simply just mix the paper in ground and it will disintegrate. So therefore, in principle, paper-based office should be better as per this particular logic. But then you are saying right now e-waste is less, so better go for this. Okay. So any other? Only 6 votes I got. Any other views, thoughts, yes or no's? Those are not yet answered until now.
Hello, sir.
Yeah. Name?
Sir, Vipul.
Yeah, Vipul. Yeah.
Sir, so I don't know which will be more beneficial because uh, I need to compare on 3 aspects. Like first will be the scale at which will be operating. The second will be the economics, like what kind of energy input we are uh, targeting as opposed to what is the expected output. And third will be if we are able to implement circular economy, like someone mentioned about recycling. So I think based on that, we can say it is quite comparable. But these 3 things should be compared.
Scale.
There's no definite answer, sir.
I
Scale,
did not get
economics.
3 points. See, first is scale, second is economics, and what is the last one? Circular economy.
Yes, sir.
I think there is a better term for this. It's called life cycle. Okay? Consider the entire life cycle.
Correct.
Entire life cycle in terms of uh, consider the entire life cycle in terms of manufacturing of paper and distribution of paper and then usage of paper, all these things.
Like
In the life.
upstream and downstream processes, and after
Okay.
that, consumption and everything.
So you said don't know, but then can you guess which one will be better in terms of environmental perspective? Should you be paperless or with paper, so that more beneficial to the environment?
Sir, it depends on the application. If you see about examinations, in some cases, like in government, they still prefer in most of the cases they prefer paper-based. But I don't know, sir, how much carbon footprint it is generating. Based on that, we can get a
Yeah.
definite.
So, anyway, so I think let's conclude this topic. See, what yeah, sorry, somebody. So if you are using phone and this thing, one of them you have to mute.
Sir, yeah, I'm Pawan. So, what I think is it is very complex right now to give a future prospect. But I'll do what I can. But when we look at it in terms of paper and paperless, there are a few aspects we need to consider. One is the amount that we're going to use. That is, if we are going to increase our population, it is going to create a silver, and there's a lot of scarce. I think in the best case scenario, our population will go down. That's the best case scenario. If we consider that, we'd be better off going to paperless. But if we think that we are going towards more and more electronic consumption, it would be very hard to get silica or even to make transistors on that capacity. Even if we refine the technology so much, getting from 0 to 95 is very easy in terms of efficiency. From getting it from 95 to 99 is pretty hard. So in terms of the transistor efficiency, I'm saying it for every physical object in place. So in that scenario, I would not prefer paperless, but go for paper. Yeah.
Okay, so what if I rephrase what you are saying is, as population increases, paperless will be difficult to keep up. Therefore, we may have to resort to paper-based.
Yes, sir.
Okay.
Yes. Sir, it sounds actually very counterintuitive. Because if the population is increasing and we are going for paper, that means we are cutting more and more trees. The problem will increase multifold. So it's actually, I don't know, it sounds paradoxical.
Who is this? What is your name?
Rizvi, sir. Rizvi. I'm not convinced on this point.
Okay. Okay. So, I mean, that's fine. Not convinced. So I would like to now make a observation here. Okay, so see, ultimately, what is my intention in conducting this course as a form of discussion thing is this only. Like, see, why are we discussing? Why are we discussing is that we advance by, analyzing different aspects of a topic. So we bring about a topic. So the topic is like this: paperless office will be more harmful to the environment compared to paper-based office. Now, how to think about it? Is it yes? Is it no? What kind of, is it don't know? What kind of things come into picture? What needs to be considered? How to consider scale? How to consider? So once you start asking a question, then the discussion will happen, and then your analysis skills will improve, and you will get more. You may not get a concluding answer, but you will get at least a general sense, which direction we are going. And I would like Okay, so I would like so all my students to learn this, skill of asking questions slash finding information, okay, formulating arguments, okay, so gathering evidence, to support your argument, and then finally making analysis, calculations or whatever. Okay, so analysis, etc. So it is not that I don't want to teach you energy management as a subject. I want to use energy management as a topic in all of you becoming like this. So the more, in fact, the most important is about asking questions. The more you ask questions, then you will get, and you can just about start anyway. See, today I was not even prepared. I just came and then switched on the call, started recording, and then keep forcing you to think and ask questions, and then slowly the debate comes and discussion comes like this. And so far we have done two topics. So one topic is about energy efficient computing, and the other topic is about this paperless office, topic about paperless. And these two are very random. I mean, it could have been anything else, and there are a lot of topics like this. See, for example, greeting cards. Should you support greeting cards or not? Somebody's birthday is there, then you give a greeting card or something like that, right? I don't know now how many people are using greeting cards, but then it's a question we are asking, like, is it greeting card is good or not? Or sometimes you send a message, there will be, instead of greeting card, it's a Diwali, so happy Diwali. So you send one image. You have 100 people in your WhatsApp group, and you send that image happy Diwali to all 100 people. Is it good or bad? So you're asking that question. Is it harmful to the nature if you send happy Diwali message to all your contacts in your working group, in your not working group, the WhatsApp group? You are getting the question, right? So we are just asking question, and you should not be what you call considered a bad person for asking a question. So nobody asks these questions. So first, as my student, I want all of you to become less afraid and more open to asking questions. And then most of the time, when you ask a question, the information is available out there. It's just a matter of finding. 10 years back or even 20 years back or whatever, we did not have common people did not have the resource to find out information in the tips of your fingertips. That is, you just take out your phone and then ask a question, you will get an answer. And then probably, see, I just asked a question, greeting cards, right? Probably somebody has done research on it. Probably somebody has done a PhD on the merits and demerits of using greeting cards. It might be somebody's life's work, and it will be interesting to you to find out. And this is way of life, not just for this one particular course, not just while you are a student of IIT Hyderabad, not just so until the rest of your life on daily basis. What is the question I want to ask today, and what is the answer I want to find today? And then you keep accumulating your understanding about the world. How do you formulate an argument? How do you gather evidence? How do you make calculations, analysis, etc. Okay. So why do you do all these things? That's another question. By the way, I mean, does that clarify my point? Why are we discussing all these things?
Yes, sir.
See, I don't like to have some kind of ready-made course material, and then we consume that information and then we write that in the exam, and that doesn't make sense in today's world. In today's world, you should be students should be more taught about how to ask questions than how to answer the questions. Yeah, so let's continue. See, we still have about half an hour. So let's make this discussion a little bit more interesting. So again, up to you. Anybody wants to, anybody wants to take the discussion some other day. And further, see here, 5, 6, 7, 8, only 8 people voted, and there are about 18 people on the call. So I don't know why other 10 people did not answer. So probably they are just not following the discussion. They just joined the call because I sent a mail today, right? There is going to be call and everything, and then they might have just joined the call and then they were doing their regular other works, keeping the phone on mute and things like that. So anyway, so let's again, I'll give it back to the floor back to you people. I have opened a white sheet of paper again. So what do we do next now? Where do you want to take this?
Excuse me, sir.
Yes.
Sir, I was going through this article on nature.com just right now, only 30 minutes back.
Okay, so
it was about data centers, how much energy they are consuming. Because when Nikhil was speaking, so I was curious, so I went to the site. Okay, so it says that the data centers consume around 1% of the total energy consumption, but ICT, which involves.
So there are different people with different estimates for this. So people have been told, they have been telling European Union's data centers consume around 100 terawatts, and there are people have estimated that in 2018 200 terawatts were consumed. There was another paper that said in 2019 that around 350 terawatts are being consumed worldwide, and so on. So I just wanted to add that before moving on.
So
in this paper it's around 200, but ICT value is more. I think it's about what he said, more around 8 to 10%. But the number that is given, that is a bit scary. That it can rise to 20.9% in 2030. That is the expected number. So that is why I said that paperless it might be more beneficial. It might be more harmful. So yeah.
So you are saying ICT, right? Information and communication technology, right?
Yes, sir.
Information and communication technology. Okay, so this is ICT. May rise its share. Energy, global, right? Global energy.
I've pasted in the chat box. There is an image. It's a very interesting image. So the data is there.
Yeah. So global energy consumption to 29%. You're saying by
20.9.
21% by. How to stop data centers from gobbling up world electricity? Okay, so energy efficient drive at the information factories that serve as Facebook, Google, and Bitcoin. Okay, you can see a nice picture of data center. So you can see all left side, right side, all these CPUs and all, and then some. Okay, so 9,000 terawatt hours, 20.9% of projected electricity demand will be network, wireless, and wired production of ICT, consumer devices, televisions, computers, and data centers.
It is rising drastically, data centers.
So by 2030, okay. So right now we are at 2020. So if I just approximately get the projection, so this is 0, and then probably this is 1,000, right? Y-axis 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9,000. So approximately 2020, let's project. So the green one is data centers, okay, and apparently yes. So did you see we got a confirmation?
Yes, sir.
The green one is data center, and data center looks like about 400. Okay, so from a different source. Okay, so refer to the chart at this link. Okay, so I'll paste this link. No. So let me paste this link. So here, one thing is we got confirmation that data centers in 2020 consume about 400 TWH. Okay, so this is one point. Okay. So it is always a good exercise to confirm your knowledge from different sources. Now, one thing is sounds interesting here. Do you see how much we are consuming in televisions, computers, and mobile phones? Yellow one. About 1,000 here, right? About 1,000 terawatt in 2010. Now, moving forward, can you see it is reducing, right? By 2030, maybe this is just 500. Is everybody able to see this? I just want confirmation.
Sir,
I think it's decreasing because it's a percentage, depicted as a percentage. So
Yes.
the amount might increase, but not as much as others.
No, I think it's depicted in total also.
This is total, right? Y-axis is in actual this thing. Yes, percentage wise it is decreasing, but not only percentage wise, it's also decreasing. What you call this consumption wise also. Do you think why it is?
It could be because they're being made more efficient, sir.
Okay, so one more point we can so how much do you think this is? About 500. This one. So let's just approximately write that. Consumer devices will become more efficient. Okay, so 1,000 terawatt hour consumption across the world, 1,000 terawatt hours in 2010 to just 500 terawatt hour in 2030. Okay, so this is a very interesting, right? Consumer devices, what they are saying, TV, mobile, what else? Clearly they mentioned that also, right? Televisions, computers, and mobiles. So this I find it is interesting. See, whenever you are confronted with information like this, one of the again good talent that I would like all the students to look at a picture and then grasp the things, what it is.
Sir, I
Yeah.
would like to add one point. May I?
Yeah, yeah,
Yeah, sir, from this graph, we can see that the blue portion, which is
yeah,
networks, wireless and wired, so that is contributing to a lot of energy consumption or the electricity demand. And
yeah,
we see yellow, the consumer devices are also rising. If we are even considering the fact that consumer devices will become more efficient, but as a consumer, we are actually shifting more towards our mobile phones. Like we are having bigger screens day by day. There was an
okay,
interesting uh, point that I was reading the other day on LinkedIn, that somebody was saying that we should actually regularize the resolution. Like suppose if you're watching YouTube on mobile, so you should actually restrict it to a standard definition, or let's say 480p resolution, as opposed to high definition, because in a smaller screen, a standard definition or a high definition wouldn't make much of a difference. So if you restrict that, it will certainly reduce the burden on the cellular networks. Given that we have Geo in India, and it's the plans are quite cheap as compared to other countries, there is more consumption happening in India. So they were saying, okay, if we try to regularize this, the content, and all the OTT players like Netflix, Amazon Prime, if they restrict this, we can certainly bring down this consumption on the cellular networks.
okay. Anybody wants to discuss on this point?
Yes, sir. As Vipul just brought up, people are moving a lot to mobile devices these days from laptops and so on. And that could be another reason why these guys are predicting a decrease in the energy consumed by devices. So rather than using a laptop, if someone uses a mobile, the energy consumption will be less.
Overall number of devices will increase.
Yes, sir. But devices which consume less power, that is, mobile phones, will increase and computers might decrease. I think that might be one of the reasons why they're projecting a decrease.
Sir, you are on mute actually.
Yeah. So this yellow one is reducing, right? So this is a client, whereas the server is located in the cloud, in the data center, right? So what is happening is the utilization at the client is reducing. I mean, the computation is reducing and shifted to data center. So what you are doing is, let's say you want to translate a message. So you collect the message sample in your phone, the audio clip or whatever, transmit it to over the network to the data center. Data center will execute the translation program and then again transfer the translated message back to your mobile phone, and then your mobile phone says that okay, this is the translation. So what is the application or use of your end device, that is client, is just to collect the information and to spread the information. The entire computation is happening in the data center and the entire network is used to do that thing. So that might be the reason why this is increasing and this is increasing, whereas the end device, consumer devices, power is reducing. Did you get the logic which I am saying?
Yes, sir, absolutely. It is happening, sir. Like nowadays, software and many things or everything is online. Like MATLAB also, I use online MATLAB. So even in my laptop, MATLAB itself is not there. So rather than using my own thing, I use the online thing. So like computation and everything happens on the data center side. I just get the GUI format in my laptop. So it is absolutely correct.
Shifted into the cloud, and the end device is only used for collecting the inputs and displaying the output. So this is a trend which I am observing. Okay, so and that is the reason why this may be the reason why yellow is less and blue and green are increasing. Okay, so this is again just a point. See, what now, given this fact, given this trend, observing this, how do you see? You are right now, you will be definitely living in the world where 2030 comes, 2040, 2050, 2060, and so on. As a person living now, how you should what you should learn to survive or to make your life better in future? Am I making my question clear? Like given the I'll just make it into a question. Okay. Given the trend that we discussed above, uh, what should I be doing slash learning so that I will be benefited, after 2030? Can you answer such a question right now? So this is
I think
does it give you some idea? Does it give you some kind of what do you call interesting path?
Sir, maybe developing new technologies of networking and maybe ICP, or yeah, make research on making the technology more better. That will definitely benefit someone if they're looking in short term like 2030.
Okay, let me just rephrase this question. See, when I say, see, I will be benefited. Okay, so you can interpret it in two ways. One is the entire society will be benefited, or you as a person individually you will be benefited. Like for example, you want to become an entrepreneur and do something. Okay, so given that this is the picture of in next 10 years, huge. See, right now, how much is it? 2020, the total energy is close to 2000 terawatt hours. 2020, total energy close to 2000 terawatt hours. Whereas by 2030, it will become 9000 terawatt hours. So the energy consumption will be 4.5 times more in next 10 years. Huge amount of energy is being consumed. So if you want to utilize this to improve your own career, what you can do?
Maybe exploring the fields like everything that is related to data management, data collection, data analyzation, all these things, and also networking.
Exploring the fields of networking and data, whatever data storage, retrieval, etc. So Sandeep is suggesting one thing: just take some time out and then explore these fields, try to understand the trends, and then maybe identify, some kind of learn some technology or whatever which will help in this particular field of networking, data storage, or some things like that. Yeah. So any other point?
Sir, it can be learning artificial intelligence or machine learning techniques to improve our consumption patterns at an individual level, or maybe
So who is
at
suggesting this?
large scale.
Vipul. Okay.
Yeah.
So Vipul. So what you are suggesting is learn AI and ML to address. But what is the problem you want to address? I did not get it.
Sir, it can be like a home automation. Let's say if it is analyzing our monthly consumption patterns, and then it helps us with some suggestions or techniques which we can improve our consumption pattern
To
at an
address
individual
the
level.
management problem.
Yeah.
Good. So does everybody agree with these points? There is some benefit in doing your own exploration, your own learning. Yeah. Any other? See, given the trend discussed, what should I be doing or learning so that I will be benefited after 2030? That's the question. So again, for your, maybe I'll just copy this image and then paste it here. Oh, there is another part of the figure also. So let me just. Okay, so I'm just reducing the size of the image, maybe to 60%. Okay. Okay, so I think there is another part here. So let's study this. Let's make it center justified. Every time you take a picture like this, you have to mention source. Otherwise, it will be plagiarism. So mention the source, okay, all the time. The source is this one. I'm just keeping being lazy and then just providing a link. Okay. Yeah. So let's see what is there. I'm sorry. Yeah. So you got the point, right? Anybody wants to add? At least 4 or 5 people should add like this. Knowing this picture, what is it telling you? Energy consumption. Widely cited forecast suggests that total electricity demand of information and communication technology will accelerate in 2020s, and the data centers will take larger slice.
Sir, get into a business, matlab start a business for making networking part like optical wires or wireless rotors or something like that of that sort, because anyway
Okay.
the consumption is going to increase.
There is an opportunity for making networking components. Okay, so this is like as demand will grow in future. See, not only making networking components, but if you are making compared to present, if you make it more efficient, definitely there is a demand. Okay, so this is again one more thing. Okay, so again, those who are in the class today, or those who are looking at this, there is no denial of this argument. Definitely, there will be this thing. So again, that's a good idea. Anybody else wants to add something here? Meanwhile, before we go forward, see one point I would like to mention how it all started. So if I go back here, Rizvi, okay, going through a Nature article on data center. When he was going through, while we were having above discussion. Okay, so probably he just spent maybe spent only 5 minutes, right? Do you agree, Rizvi? In
Yes, sir. 10-15
article. Okay, so this is a very interesting point that he just spent. Sorry, that sound is from my son. So just spent 5 minutes finding the article. Okay, and then it is giving so much direction, it's giving so much ideas for the entire future. Okay, so that is the power of today's knowledge world. Okay, so did you get the analogy or which I'm making?
Yes, sir.
So what's your thoughts on this? Yeah, so what I was saying, just spending few minutes and identifying a resource like this, and then sharing with everyone, and then keenly observing it, and then drawing out conclusions, making some formulating plans for your future. So this is as simple as this actually. So if you keep doing this instead of spending 5 minutes, let's say you spend 3 hours. Definitely you will learn, you will get so much knowledge, right? So for example, we have let's say we have about 25 students. Okay. I think there are 28 students registered in this course. Okay. So out of that, let's take only 50%. 14 students are interested. And then spend about 3 hours per week, or maybe let's say spend 2 hours per week. I don't know. I think we are just about to conclude this course, right? I think 2 weeks are there. So about 4 hours only is there. Okay. So in next 2 weeks, so we will have 14 into 2 into 2, which is like how much?
56.
Yeah, 56. Okay. So 56 hours of research and notes making. Okay. Then you can just say share with everyone. Okay, so the 14 interested students plus 14 not interested students, because I can't expect everybody to be equally interested in, plus many more on YouTube. So it will be very interesting thing, right? So if you can kind of spend this time and write down some, see, I just, how many pages I wrote? Only two and a half pages. And in this 2.5 pages, we have captured good, interesting discussion, right? And it's about a 1 hour video, 1 hour 15 minutes YouTube video we have made, and it's quite interesting. We did not discuss this diagram, and we did not discuss this diagram also. Anyway, so yeah, so it will be interesting, right? So I would like to say, what is your assignment for the next few sessions? Okay, so I'll remove this. Okay. Explore more topics like this. Spend at least 2 hours per week. Not the class time, but additionally. Explore more topics like this. Make notes. Keep it interesting. Create arguments. Okay, and then come to class and discuss. Okay. So I think I'll stop here. Anything else you want to add? Did you like this format or whatever I'm doing? Do you think I'm making sense? Is it a better utilization of your time?
Yes, sir.
Yes, sir.
Yeah, so everybody should attend, and I don't know. Yeah, most of people are attending and keeping on mute, so that also you should avoid doing. And please contribute to yourself, make the discussion more rich, and make it interesting. Let's quickly, in last 1 minute, we'll look at this. The chart above is expected case projection from Anders Andri, specialist in ICT. Best case scenario, ICT grows to only 8% of total demand by 2030 rather than 21. Okay. 2015 other demand, best case, expected case. Internet explosion. Internet traffic is growing exponentially and reached more than a zettabyte in 2017. Okay, so you can look at 1987, the small dot, not even, you can see that. Then a little bit dot, it was in petabyte, then it became exabyte, and now we are in zettabyte. So I think we will stop at this. So continue your work. You can take up the same topic and go more in depth, or you can take up some other topic related to energy, and we will discuss that. I hope you are all learning something by participating in the conversation. So,
Sir?
yes.
Sir, this is regarding IDP. Like you said, you would mentor my project.
Yeah, so we'll discuss maybe after this. So I'll just end this session. You can
Okay,
stay
sir.
back. You can stay back. I'll stop recording. Yeah.
Okay, sir.
Thank you.
Thank you, sir.
Thank you, sir.